Alright guys, you are welcome back to this class lesson. In the course of today's class lesson, I'll be teaching on the subject chemistry. Alright, so let us start right away. Pay attention. In the course of today's class lesson, I'll be tackling these aspects of chemistry called Graham's law of diffusion. It is very essential in the JAMB exam and other, chemistry related exams. So you have to pay close attention to every information to be shared in the course of today's class lesson. Though we have worked on this before, but it is essential I talk about it because in the course of today's class lesson, I'll be solving questions pertaining to this area, like topic. The one Jam have asked so far. That's what we'll be solving. So get ready. Graham's law of diffusion is a gas law alongside the other gas laws like Boyle's law, Charles' law, ideal gas equation, the combined gas law, which we call the general gas law, and Gelux's law of combining volume, all of these laws. But in the course of today's class lesson, in the course of today's live class lesson, we'll be tackling this aspect, and after tackling this question area, then we go over to other areas that Jam have asked so far. Alright, so let us do that right away. Let us quickly start. There is no time to waste. Alright guys, let us go. If you are online, do what to signify. Alright, if you are online, do what to signify so we can, start. If you are online, do what to signify so we can start right away. So the first question we ask ourselves, because I'll be tackling questions Jam have asked so far on this area. Please listen. Alright, I already have the questions here. Here. Alright, let me quickly go to the Jam asked question and go to the part of this Graham's law of diffusion in chemistry. Then after every single explanation, we are going to go and look for questions that pertains to everything we'll be talking about. So please, you have to open your ears and listen because all these questions are so childish. Alright? So guys, I believe the network is okay. I believe everybody can hear me clearly. I believe everyone can hear me clearly. I believe everyone can hear me clearly. Please let me know in the comment section. Alright? Let me know in the comment section if everybody can hear me clearly. Alright, no problem. Let us move further. Everybody, first of all, the first question we ask ourselves on this law, because it's a law that comes out in the JAM chemistry exam a lot, and other laws, questions on other laws which you have tackled already. But let us play with these and other things in the course of this live class lesson. Graham's, what does this state? Graham's law of diffusion, please listen, write it in your note. This law states that the rate of diffusion of a gas. This law states that the rate, you can see this, the rate of diffusion of a gas. Diffusion has to do with movement of what? Substances. Be it gases, be it liquids or solid. But this law is focusing on gases. Are you there? That's why it's called gas law. So Graham's law of diffusion states that, right? The rate of diffusion of a gas is inversely, I did not say directly, is what, everybody? Inversely proportional. Alright? First of all, I said inversely proportional. Everybody listen. This on the board is, they call it proportionality sign. I believe you are aware about that, alright? That is called proportionality sign, right? Proportionality could be direct or inverse. But in this law, Thomas Graham, he said, the rate of diffusion of a gas is inversely proportional. Now, when something is inversely proportional, okay, inversely proportional, relax, to the square root of its density, or inversely proportional to the square root of its relative molecular mass or molecular mass. Relax, I will explain. Now, when something is inversely proportional, it doesn't mean that thing is inversely proportional to that thing, pay attention, or rate is inversely proportional to 1 over that thing, everybody. What do I mean when I say something is inverse? It is simply 1 over that thing now. This is simple mathematics, alright? So basically, everybody, when they say something is inversely proportional to something, it simply means that, for what I said, rate of diffusion of a gas is inversely proportional to the square root. This is this square root? No, now. This is squared. Alright? To the square root, are you following me? Of its density, pay attention, or we simply say that the rate of diffusion of a gas is inversely proportional to the square root of its what? Molecular mass. Alright? This is what this man, Thomas Graham, was talking about. Guys, pay attention. It is very essential. Alright? Pay attention to what I'm saying. It is very essential because we're going to tackle questions on all of these. I repeat, according to this man called Graham's, he said, the rate of diffusion, are you not seeing rate? The rate of diffusion of a gas is inversely proportional to either two things. It could be inversely proportional to square root of its density, or inversely proportional to what, everybody? The square root of its what? Molecular mass. Hope you guys are following me. Hope there is no network problem. Alright? I hope there's no network problem, right? Everybody take note of what I just said, though. Square root. I did not just say rate is inversely proportional to density. This is not what I said. I did not say rate of diffusion of the gas is inversely proportional to density. That is not what I told you. I did not tell you this about Graham, so no, nah. It's not just density. You must tell me that it is square root of density. And also, I did not tell you that rate of diffusion of the gas is inversely proportional to what? Molecular mass. I did not say that. I simply told you that square root of what, everybody? Molecular mass. Alright? I believe everyone is following me. Alright? So I can wipe the board. So these are the two expressions, the correct expression for what this Graham's equation talks about. Because in the course of today's class lesson, we are going to be able to solve any question we see on Graham's as far as the JAM exam and other chemistry related exams is concerned. Just open your ears and listen and show you are writing. Alright, I'm about wiping the board so I can move forward. Let me know if I can wipe the board, guys. Let me know if I can wipe the board. Can I wipe the board now? Alright, good one. So I'm about wiping the board so I can rewrite some vital things. Wipe the board, everyone. Alright, I want to wipe the board, everyone. I believe everything is okay, right? So I'm going to wipe the board. And anywhere I teach So when I teach anything, I know that Jam have asked it before. I'm going to ask us the question. So you can see that all these things are very childish. Alright. So in the Jam pass question, I've gotten to the part of Graham's. We're going to finish out the questions today. Alright. So that is for that. Everybody pay attention and listen well. Pay attention and listen well. Very essential. Alright. Very, very essential. Very essential, guys. Alright, so that is for that. Alright, so let us move further. Let us what? Move further. On these grams, what this man was talking about. So everybody, we have established the fact on what this man was talking about. Relax. I want to rewrite the mathematical expression. Alright, according to Graham's, he said that the rate of diffusion of a gas, is it directly or inversely? Inversely, you don't ever forget. Inversely proportional to square root of its density. Everybody pay attention to what I'm saying. Or if you don't say this, you can simply say that the rate of diffusion of a gas is inversely proportional to what, everybody? The square root of it, what? Molecular mass. I know why I'm stressing on all these. It is very essential. Alright, it is very essential. So I'm going to move further and tell us something that is very important also. You know, if they say we should derive the formula for this expression, we can do that. Everybody listen, just listen. This is what I'm going to do. Remember, in all of those your Boyle's law, Charles' law, anywhere you see a proportionality sign in science and you want to derive a formula, what do you do, everybody? You introduce a constant, and that constant is symbolized as K or anything. Let's introduce a constant into this and into that. Listen, if we are to introduce a constant, these are proportionality sign. We change to what is inside this bracket, equal to and K. We have been able to introduce a constant, so you put equal to in front. Now, everybody, this is what I'm saying. So I want to rewrite these two guys by introducing a constant. Look how it works. So here, for the first, that says rate of diffusion. Removing this, introduce a constant, is going to be equal to K. Are you there? Alright, I say 1. We've just removed this and just equal to again. That's what I told you. So this one still remains the same. 1 over root of what? Density. Class, are you following me? Hope it's making sense to you. Yes, now. Now, what do we do next? I want to further break this one down. I'm on this. I'm not gotten to this yet. Just relax. So, we will not care with times 1. Yes. This has the ability to times 1. Doing that, rewriting this, rate will now be equal to, alright, K times 1. Anything, yes. This K will times 1 for sure. It will times 1. Okay, let me look at something so that it will not confuse you. Alright, just listen, look at what will happen. I want to simply just bring it down, alright. 1 over root of what, everybody? Density. Yes. We remove this proportionality and put equal. Okay, that's why I told you there. Alright? So what do we do, everybody? We now say our K will times 1, K times 1. Anything that's 1, is it not that thing? Have you forgotten? So equal to remains, and then K times 1 is what? K all over. There is nothing to times for the root of density, so you will rewrite it. Are you following me, everybody? Please pay attention. So you can see what we've been able to establish from this. We will be able to form rate is equal to K over root of density. It is not hard, everybody. Let's do the same for this one that is down. The same thing. Alright, rate of diffusion of the gas. Now, removing the proportionality sign, putting equal to and K, and here becomes 1 over root of what, everybody? Molecular what? Mass. Because there is a jump question on this. Relax. So what next we do? K times 1, remember, it's going to be K. So rewriting it, rate will now be equal to what now? K all over root of what? Molecular mass. I know I'm saying this, alright? It will help us a lot. Hope you guys are following me. You can see what we have established. So you can see from these two expressions, expression down. Alright? Hope you guys are following me. Alright? Hope you guys are following me. I know why I'm saying this. There is a jump question on this thing I just said. Alright? There is a jump question on this thing I just said. Please, let me bring that jump question out so that you guys know that all these things are not hard. Alright? All these things are very cheap. I've seen it. You can see jump people. They are not just, jeez. Alright, let's work it out together. Here's the question. It says, the question Jam asks, let me see how smart we are based on my explanation. Relax, let me quickly write on the board before you copy everything. So the question says, everybody, it says, if D represents, alright, then I told us, if D represents, what do you call it, the density of a gas, alright? Remember, we've been talking about density. And they are telling that D represents the density of what? A gas, everybody. Alright? And K, which is a constant, is a constant. They are telling me now that K is a constant, which they have told us already. Alright? They now said, okay, the rate of diffusion is related to, okay, the question now says, the rate of diffusion of the gas is related to, look at option A. Relax, let me write the options and let's work it out together. Option A says arrow. This small arrow you are looking at, it simply means rate. And you for that's what they want us to know. Alright, arrow is equal to what? K. Alright. Okay, wait. Arrow is equal to KD. Option B says arrow is equal to K over D. C says arrow is equal to, okay, R is equal to K root D. And option D now says R is equal to K over root D. Everybody, let's tackle this question together. It is so cheap. You have to be smart. Wow, I'm so proud. No, who is doing that now? Lillian. No, don't do that, please. Don't do that. Please, don't do that. This is simple. What did I just tell us? I've derived the formula for rates that relate with density and also rates that relate with molecular mass. Relax. And how was their relationship when we did our derivation? We established the fact that rate is equal to K divided, this thing is divided, over, divided by root of density. That's what we said. So that is the relationship between rate and density. What is also the relationship between rate and molecular mass? The same. Rate is equal to K all over root of molecular mass. Pay attention. So which of these expressions, because the question says if D represents density of a gas and K is a constant, the rate is now what? They are not asking, okay, how do we relate rate, density, and the constant? How? Is it rate, molecular mass, and constant? No. It is rate, density, and constant. So it is this. Rate, density, and constant. How do we relate all of them? Simple now. Rate, which is that small arrow they wrote there, we must look for the expression that looks like this. Though you can see now the way they wrote it. Instead of them to do the divide like this, they wrote it like this. So they want to make you confused. But you should not be confused. Because missing this, it means divided by. Now is the answer A. Did I tell us that rate is equal to K times D? Is it K times D? Is it what I told you? No now. So option A is wrong. Is it rate is equal to K over D? Is it just K over D? I told you. It is K over root D now. That's what I told you. B is wrong. Is it just R is equal to K times? This thing means not seeing any divide, it means times. K root D is what I told you. Is it K root D or K over root D? K over root D. Answer to the question D. You can see how cheap the question is. It is not difficult at all. I believe this is clear to everybody. So we can move further. Let me know in the comment section so we can move further, guys. Do that now. I believe it is clear. Is it clear? Is it clear? Is it clear, everyone? All right, good. So that is for that. Meanwhile, just give me a few minutes. I'm coming back so we can continue. So we can continue, guys. Just wait. I'm coming. All right, very good, very good. So can I move on now? Can I move on to the other things we have to learn? Because there are a lot of things to learn here, but they're all easy and childish. Can I move on, guys? Remember we said that we are going to trash all topics, all questions rather, that pertains this in the course of this live class lesson that JAMB have asked all over, like all the years, all right, since 1978, all right. So right now, I'll be wiping the board. We have established a very strong, foundation. As a student, you have to get a very good foundation in anything you are learning. So I'm going to wipe the board, all right, so we can move further. I believe we have written all these, so we can move further. So we can move further, guys. All right, so that is for that. That is for that. All right, another thing to learn here now. Another thing to learn here. Everybody, I am interested. See, listen, I've defined what Graham was talking about. So just bear this in mind. That two expression we have written on the board will help us a lot. So as a student, if you don't remember those two expressions, there'll be a problem in this aspect. But since I have given us already, there will not be any problem. So those two expressions I just wiped on the board. I want to rewrite it also on the board to tell us something else. Everybody, I want to write them. I like to write a lot. All right? So rate again from what we said, from what the law says, that the rate of diffusion of a gas is what? Inversely proportional to what now? The square root of its density, or we simply say that the rate of diffusion of a gas is what? Inversely proportional to the square root of its what, everyone? Molecular mass. Hope you all know all of these things, right? So everybody, relax and pay attention. There is something I want to tell us here. All right, there's something I want to tell us here. There's something I want to say right now. In science, when something is inversely proportional to another thing, it simply means that when another thing, let's say this is one thing and this is another thing, right? So let's say both of them now, they are inversely proportional to each other. The way rate is inversely proportional to square root of density, and also rate is inversely proportional to square root of molecular mass. So when you hear inverse proportionality, it simply means that as this thing here increases, this one you are seeing right now, the marker you are seeing right now will decrease. Are you there? As I go up, the marker comes down. That is inverse proportionality. But if it was direct proportionality, as I go up, the marker goes up. As I come down, the marker comes down. Are you listening? So it is inverse. As I go up, the marker comes down. If I decide not to go, no, I'm not going down, alright? Alright, so you get what I'm saying, right? So if this calculator now is to go down, the marker will go up. Do you understand? If this marker is to go down, this one go up. Do you get my point? That is inverse. Inverse. Put that in your mind. Alright? Put that in your mind, everybody. Very, very essential. Alright? Very, very essential. Alright? So, what will happen here is this. Everybody pay attention. I want to form an equation that is essential for these two expressions. I'm not going to do derivation. I will just tell us what to do. Everybody from this, let us form our equation. Remember I said as rate goes up, density goes down. As density goes up, rate goes down. Same applies to this. As rate goes up, molecular mass goes down. As molecular mass goes up, rate goes down. Are you listening? So let us move further. Everybody, I want to form a formula based on these two expressions. Relax. You know, in gas laws, we relate different gases. This is what I mean. So we're going to have two sets of gases. Everybody listen. This is rate. So I want to write something. Rate, everybody listen. This is serious. Alright, this is serious, so take it seriously. Rate 1, I said we are relating two sets of gases, divided by rate 2, everybody. I'm not deriving formula, I'm just trying to tell you, you have to be smart, alright? That's what I'm giving. I'm giving you guys smart ways to do things, alright? Just relax. Now, you can see what I've done. I said rate 1 over rate 2. How is the rate going? Is it not from 1? We have to be smart. Is it not from 1 to 2? Yes, it is. So what we now put to root of density? Root of density will now go from the opposite direction. Relax. So the next thing I will do next, everybody, we simply put equal to. Everybody, what did I say? We put equal to. Follow me. Then I will come here and say one very big square root. Everybody pay attention. I just say big square root I'm writing. In this big square root, I'll still divide two things. But I'll divide density, because density has a square root. Alright? But since it's inverse, if this is inverse, how will it work everywhere? Here went from 1 to 2. What will happen to density opposite? 2 to 1. So, from what I've said so far, as rate increases, going from 1 to 2, density decreases, going from 2 to 1. So, look at how it works. You can see the first expression I have formed. Everybody open your ears and listen. Rate 1 over rate 2 is equal to root of density 2 over density 1. This is not cramming. Understanding is key. Alright? Understanding is key. Alright? Understanding is very vital and key. Class, can I move on now? Have we gotten this? Let me know in the comment section. So we can do the same expression, from the same formula for this second expression. Let me know in the comment section so I can move further. Let me know in the comment section so I can move further. Bear in mind that we have a lot of questions to solve. Alright, so you have to pay close attention. Everyone, let us move further. So, look at what I've said. Let's form the same expression. It's between rate and root of molecular mass. The same pattern. So here I simply come here and say, relating two set of gases. So rate 1 divided by rate 2, everybody will now be equal to a very big square root of molecular mass. And how will it work? Molecular mass 1. Sorry. 1 to 1, 2. So molecular mass 2 divided by what, everybody? Molecular mass what? Molecular mass what, everybody? 1. You can see the point I'm trying to make here. Class, hope is making sense to you. As rate increases, molecular mass decreases. 1 to 2, 2 to 1. Class, hope is making sense because we are going to solve all questions Jam have asked on this aspect. Alright? I believe you guys are following me. Alright? I believe you guys are following me. Alright. So that is for that. You can see the so far, how many formulas have we established on this aspect of Graham's law of diffusion? 2. In today's class, we will talk about a lot of formulas, but they are not hard to remember. They are easy. Just understand, have a firm foundation. Very important. As a student, you have to have a firm foundation in things, alright? So that is for that. So, the third formula, everybody. I'm about to give us the third formula. Look at it. That third formula is the formula for rate. Everyone, what is the formula I'm about writing? It is the formula for, they can say, okay, what is rate? Rate is the something tells something. Let me tell us. Mathematically, rate is equal to volume of a gas. So we simply say volume divided by time. Everyone, I repeat what I just said. Mathematically, what is rate? Volume of a gas divided by time. You know, this divide sign, you can call it per. Divide is per something. So volume per time. Volume of a gas per time. Alright? So this is the third formula we have established, alright, on this aspect. Alright, so that is for that. So let me just give us the unit for rate, alright, based on the one that your JAM expects you to know more and the one that is common. I'm aware that volume can exist in different units, but the commonness to which volume can express in will be expressed in rate calculations on gas law is volume expressed in cm cube. Hope you guys are following me. And time, what is the basic unit for time? Time should be expressed in what, everybody? Seconds. So based on this, what becomes the unit for rate? Centimeter cube per, everybody, this means per seconds. Class, I know I said this, you know, physics, you are expected to learn units, alright? So the unit now for rate is what? Centimeter. You know, unit is gotten from how the formula is. The formula is volume over time. So the unit will be, what is the unit of that volume? Centimeter cube. What is the unit for the time? Seconds. So centimeter cube per second. Alright, it is pronounced as centimeter cube per what? Seconds. That's how it's pronounced. Hope it is clear because this will help us a lot. So far, how many formulas have we worked on, everybody? 3 formulas, alright? 3 formulas on these Grahams, alright? Alright, so that is for that. That is for that, because I'm interested in solving questions in the course of this topic. A lot of questions. Alright, so everybody pay attention, very essential. Alright, so can I move on now? Can I move on to tell us something else? Can I move on to tell us something else? Remember, there are a lot of questions here. There are about 16 questions. 16 questions. Let's see how it goes. Alright, let's see how all of them goes. Let us see how all of them goes. Alright, so let us move further, everybody. Let us move. All these things are so childish. Alright, they are so childish. I'm coming. Where are you? Where are you? Okay, I've seen it. What I'm looking for, I've seen it, guys. Without wasting time, I think, should I do the derivations first? I think I should do the derivations of these formulas first before I now start solving questions. That would be better. Let me do my derivations, and then we'll start solving questions. That is okay, right? So everybody, have this in mind. How many formulas have we established on? Is it not 3 formulas? Let us work on more other formulas. I know why I'm saying all these. They are very important. So right now, okay, I think I will use this back of the board to give us the other set of formulas. Everyone, open your eyes and listen to what I'm about to say. It is very, very important. Alright? So I don't know why the board yet. Alright? Because all these other things are very essential. So, everyone listen. Let us do some derivation. Let me tell you something. You know, in mathematics, me having rate is equal to volume over time. What is now, everybody listen, how does these 3 guys, there are 3 informations here in this formula: rate, volume, and time. How does these 3 guys relate with themselves? That's the question we ask ourselves. Very easy. Everybody listen, let me tell us. Are you not seeing now that the volume is in the numerator and the time is in the denominator? Yes. So how does rate relate with volume? That's one question. And how does rate also relate with time? Let me just tell us. Parameters that are in the numerator, relating it to what we are having as the subject of formula, it is always direct proportionality. A, not big. It's not a big English. What I just said is not big. Rate and volume. How are they relating with themselves? Let me just tell you. The way rate and volume is relating is direct proportionality. I repeat, rate and volume, they are relating with themselves with what? Direct proportionality. I know I just said this. We have established the fact that when something is direct proportionality and inverse, we know the application. What is the application of something being direct? A rate, volume, direct proportionality. What do I mean by that? Very easy. It simply means that as rate increases, volume increases. Are you listening? I repeat. As rate increases, volume will increase because they are directly proportional. You can see this one is in the down part of the formula. Is in the denominator. It simply means that they are inversely proportional. Everybody listen. So what does it tell me? It tells me that as rate relating with time, as rate increases, time decreases. As time increases, rate decreases. Class, are you there? I know why I'm saying this, it will help us a lot. I know why I'm saying this is going to help us a lot. Alright? I know why I'm saying this is going to help us a lot. It's going to help us a lot. Please, I beg in the name of God. Alright? I beg you, in the name of God, please learn all these things. Somebody said chemistry made easy with pride. I mean, not pride. Alright. I know I'm saying the reason I had to, quickly try my best to make these things easy. Just, chemistry, I don't like to see the fact that students are struggling. Students are struggling with things that I know that is not hard. The other, I hate it. When I see them, like, you don't know this thing? It's very easy. Alright? It's very, very easy. Alright. So let us move forward. I repeat. You know now, what is the relationship? Quickly. What is the relationship between rate and volume? Direct. As rate increases, volume increases. As rate decreases, volume decreases. Are you there? But what is the relationship between rate and time? Because time is in the down part. So definitely it's going to be an inverse proportionality. Yes. Though I'm not showing you mathematical way to actually do all of these things, but it is very wise for you to quickly catch it. As it's in the denominator, relating it to what is in the subject, definitely is inverse proportionality. So rate increase, time decrease. Time increases, rate decreases. Class, does that make sense? Because I want to do something now on the board. Everybody listen to what I'm on to say right now. Listen. So in this part of this box, I want to start writing some formulas. Alright? In this part of this box, I'll be writing some formulas. Alright? In this part of this box, I'll be writing some formulas. So the first set of formula I want to write is the formula that relates volume, because the JAMB exam do set questions on this. Alright? It's a formula that relates what I'm about writing. And it is a formula that relates volume and density. Everybody, are you not saying volume and density? Is it that you cram? You don't cram. Don't cram these things. Don't cram it. You cram it is a problem. Don't cram it, guys. Understanding is key. Understanding is key. Class, they can give you a question, and the question will solve questions soon. The question will be relating volume and density. So as a student, what will you do? How do you even get the formula first of all? When you practice first and you want to start something, it will be easy for you. I try my best to make it very easy, so you not go at your own pace. Me, when I see questions on all these, I don't waste my time. I quickly rush the question. You can see what I said. I rush questions. Alright? I don't just solve it. I rush it and get answer. But because I'm explaining, I'm trying my best so everybody can follow me. And I believe everybody's following me. So how do we relate volume and density? Simple. So to relate volume and density, to bring a formula that relates volume and density, you basically first of all do this. You try and think, how does volume, because what rate gave birth to two things. Rate gave birth to two things. In rate, there is volume. In rate, there is time. Are you there? So now, as a student, you now think, okay, this is my parent. This is my, this is where I'm from. So how do I relate with rates? Do you understand? How do I relate with rates? That's what you check first. Leave density part and talk about volume. How will volume relate with rates? That is what you think as a student. And I believe I've explained to you guys that, the way volume and rates relate is direct proportionality. Meaning that as rate goes up, volume follows, volume goes up. As rate comes down, volume comes down. Meaning that volume behaves like rate. I'm trying to use simple words. I'm trying to use simple words. Alright? If it's an engineering person that's in this now, we'll be like solving, putting many expressions on the board. But I'm just trying my best possible to allow everybody to flow. Not that I cannot do all of those things, but I'm trying my best possible so everyone can flow. Do you understand what I'm saying? I'm using just simple words, so everybody can flow. Alright? So, as I'm saying, volume will not behave exactly like rate, because if rate goes up, volume goes up. Are you there? So as a student, you now go back to how rate is relating with density, because this time around we want to relate volume and density. So we now go back to what happened. We now go back to the fight that happened between rate and density. How did rate behave with density? Because we have agreed now that volume and rate, they are literally the same. They behave the same way. They are not the same thing. They behave the same way. Do you understand? So you now go back to the history of how rate relates with density. Oh, this is how rate related with density. Oh, I wrote rate 1 over rate 2 is equal to this. This one will never change. This is the Bose. This is the Bose. This is the atom. This is the Bose. You know how we used to do these things back then, right? So now we're not going, oh, volume is going to behave like its forefathers. Are you following me? So because rate has 1, 2, volume will have the same thing. So we'll come here and say volume 1. So the way volume and density relate is volume 1 divided by volume 2 is equal to square root of what, everybody? Density. Don't change this thing ever. Look like that. Density 2 over what? Density 1. So in summary, how does volume relate with density? Exactly the way its mother related with density. That's how we're going to relate. Why? They are directly proportional. Class, is it clear? Does this make sense to everybody? Let me know in the comment section. Let me know in the comment section. Let me know in the comment section if this I just said is making sense to you. Let me know. So because I know to all the derivation and tackle, there are about 16 questions I've seen here. We're going to tackle them. All right. Good one. Good one. Good one. Are you listening? So I want to bring something else. Let me draw another box up here. I'll be using these two set of boxes because just listen, I don't want to wipe the board yet. So I'm using these two set of boxes. This box and this box to begin my derivation. So this is now, what formula is this now? This is formula 1, this is formula 2, this is formula 3, and this is formula 4. So here now, we now be okay, how will this same volume relate with molecular mass? That's the next question. Very easy now. Exactly. You know, molecular mass, everybody now, molecular mass and density, they behave the same way now. It's not 2 to 1, 2 to 1, they behave the same way. They're not the same thing, they behave the same way. So and you know volume. So if two of them behave the same way, that means volume will also relate with molecular mass the same way it's related with density. So mathematically we now have volume what, everybody? Volume 1 divided by volume 2 is equal to square root of molecular mass. Everybody hope is clear. Molecular mass what? 2 divided by molecular mass 1. Hope you are seeing my writing. Sorry guys. Hope it's clear, right? So volume 1 volume 2 is equal to all root of what now? Square root of what now? Molecular mass 2 over molecular mass 1. You can see the way volume related with density and same volume is relating with what? Molecular mass. Class, is it making sense to us? This one I just said, does it make sense to us? Does it make sense to us? Let me know in the comment section. Alright, does it make sense to us? Let me know in the comment section. Does it make sense to us? Let me know in the comment section. So based on what I've said, everybody, how does now volume relate to density and how does volume relate to molecular mass? Simple now. It's something you can just simply tell me. You can see volume is going from 1 to 2, density is going from 2 to 1. So is there direct proportionality or inverse? Tell me in the comment section. Let me see if you guys are catching up, if you guys are following. I will send it now. Okay, first of all, how did rate relate to density? From the law, rate of diffusion is inversely proportional to square root of its density or square root of its molecular mass. So definitely, since volume and rate they behave the same way, so volume will also be I will not say it. Let me see if you guys are following me. Alright. So how will volume now relate to density or molecular mass? Tell me now. Don't go tell me directly here. I will not be happy. Don't do that. Why will you tell me direct proportionality? It is inverse now. From your mathematical expression. 1, 2, 2, 1. You have to be smart. If it was 1, 2, 1, 2, you will not say direct, but that is inverse. 1, 2, 2, 1. Inverse proportionality. Class, does it make sense? Does this thing make sense? I hope it's making sense. So how does volume now relate with molecular mass? It is also what? Inverse. 1, 2, 2, 1. So volume and molecular mass, they are inversely proportional to each other. Alright? They are inversely proportional to each other. They are inversely what? Proportional to what? Each other. Alright, so we have established that fact too. So class, I'm going to the board. So how many formulas have we written so far? How many formulas have we written so far? We have written how many? 1, 2, 3, 4, and 5. Let us move further to talk about more. Alright? And after I'm done with the formula, derivation, and all the formulas, then I'm going to start solving questions. We have solved just one question so far. We saw the question right when we started. So we are going to solve a lot. In the past, I saw 16. But don't worry, let's work on the one we can. But we're going to work on them, a lot of them. Alright? So I've cleaned the box so I can pour other vital things that are necessary here. So, everyone. So, listen. So let's relate, relax. This is what we're going to relate now, time. How does time and density behave? How does time relate with density, everybody? Very easy. Look at now. Now, remember, for you to form any formula, you look at how that time relates with, you look at how time relates. You look at how time relates with rate. That's what you are to watch out for. How does time relate with rate? Everybody, I repeat. How does time relate with rate? Is it not inverse proportionality, time and rate? Look at it now. I taught us this many times. Time and rate is not inverse. So definitely, if you want to relate, normally now, we now write, okay, time divided by time, you are aware about this, is equal to all roots of density. Everybody over what? Density. Remember, I told you, never alter this thing. Don't alter it, leave it like that. So density 2 and density 1. So how do we write our time? Time now. Everybody listen. How does time relate with rate? Is it not inverse? Meaning, if rate is going up, time goes down. So in this case, now we now look at how rate relate to density. How does rate relate to density? Is not 1, 2? Yes now. So since time and rate now is inverse, so time will not behave like rate. Volume behave like rate. Time will not behave. Stubborn. Time will now basically now go in opposite direction. Instead of it to be 1, 2, it will now be 2, 1. Class, let me know. 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 Does this make sense? So if you observe right now, it's not telling us that, oh, the way time is not behaving with look at rate is always fighting at density. You can see that rate is not even following its family. Rate is behaving somehow. Because these two guys, they don't always agree. Alright, it is inverse. So automatically now, rate and time is not directly proportional to density. Are you not seeing that 2, 1, 2, 1 going the same direction? So if this guy goes down, if this guy goes up, look at that. This guy went down 2, 1. This guy also went down. If this guy had to go 1, 2, this guy also go 1, 2. That is why we can form another expression and simply write, okay, this thing and what I'm going to write now, time 1 over, everybody listen. Over time 2 is equal to root of what? Density. Let me do D. Not to write D instead of writing density of space. D1 over D2. Class, are you aware that this formula and this formula, they are the same thing? Yes! Why are they the same? Because it is a direct proportionality. Anything that happens, they are the same thing. I just said going from 2, 1, 2, 1. So if I want to use this formula to solve or this formula to solve a question, we are going to arrive at the same answer if we did correctly. Everybody listen. In summary, time and density, they are directly proportional. But time and rate, they are what everybody? Inversely proportional. What we have established initially. Class, does this make sense? So, this formula and this formula are the same thing. So quickly, let us relate time. Everybody pay attention, very important. Let us relate time and molecular mass. You know, anything happen to density will happen to molecular mass. The same thing, everybody. So look at how it works. Time. Everybody, how does time relate to rate? Now it's not inverse, so automatically it will not be in that direction. Time 2 over time 1 is equal to the root of molecular mass. Molecular mass will never change. Always write it in with molecular mass. What do you call it now? 2 over what, everybody? Molecular mass 1. Class, hope this is making sense to you guys. Hope what I'm saying is making sense. Is it making sense to you? At least I'm trying my best possible to ensure that everybody follows. That's why I'm taking this pain right now to do all of these things. Alright? So you can see how it works, right? You can see how it works, everybody. Does it make sense to us? Does this make sense to us? Let me know in the comment section if it's making sense to us. So you know that this thing can also be written as they are directly. So I can automatically say time 1 over time 2 is equal to the root of molecular mass 1 over molecular mass 2. You can see like any direction one goes, the other goes that direction. Because if I went from 2 to 1, this one will also go from 2 to 1. This guy went from 1 to 2 or 1 to 2. Like they are literally the same when we use it to solve questions. Class, I don't know if you, not I don't know, you guys understand, right? Does it make sense? Does it make sense? This is simple mathematics. It's not hard. You can see the formulas we have worked on, everybody. Alright? So let's move further. We'll soon start solving questions. We'll soon start solving questions like very soon. But for now, let us get a firm foundation. Let's get a very strong foundation on these grahams. Everything. We're going to trash everything that pertains here. Everything. So class, can I wipe the board now? Can I wipe the board now? Alright. I'm going to wipe the board. I want to wipe the board, right? Can I wipe it? I want to wipe this and that. I want to wipe everything inside the boxes. And write the next set of formulas. And after I'm done with all the formulas, we can trash questions together. Everybody, these things are not hard to, they are not hard at all. They are not hard at all. Just your own is listening and you are free. You will be free from any form of problem. Academical problem. Alright? Anything that has to do with your academics, as far as chemistry is concerned, you'll be free. Just listen. Just what? Listen. Alright. Alright guys, let us move further. So let me write another set of relationships so we can form their formulas together. Let's say we have volume. Everybody listen. We have volume, we have time. And also we have density. How do we relate these three guys together? Bear it in mind. Density will always stand on its own. Will always be after the equator. I'm just doing this thing so that at least we can understand it. Even if you are not an engineering student, you still be able to understand these stuff now. You understand? So that is for that. Volume density will stay on its own. Whether volume and time they are from one period, now which is what? Rate. So they will be one side. Everyone listen. So your formula you are going to write is simply based on how both of them are relating with rate. Remember, we've established about that volume and this one they are directly proportional. Whether volume and time, whether time and rate are inversely proportional. So this is how the formula works. So I'm using small letters so that we can quickly write it. V now. V is volume. Alright, so we write volume. So how does volume relate to rate? Is it not the same way rate is? So volume over volume 2. Are you guys listening to me? Are you guys listening? Like volume 1 over volume 2. You see comes up here. And how does this time relate to rate? It is opposite. Time 2 over time 1. So from this, it's now like volume 1 times 2. Volume 1 times time 2. Relax. Divided by volume 2 times time 1 is equal to this. All square root of what, everyone? Density, it doesn't change. Density 2 over what, everyone? Density 1. Is this thing making sense to you? Let me know in the comment section if what I just wrote on the board, the formula I just wrote, if it's making sense to you so we can move forward. So let's quickly come here and say, okay, what's the relationship between volume, comma, time, and lastly, molecular mass? Let's do it together the same way. The same what way? So we say volume 1 all over volume 2, they always behave the same way. So how does time now behave with this? They are opposite. Time 2 over what? Time 1 is equal to square root of molecular mass 2, doesn't change, over what, everybody? Nm molecular mass what? 1 molecular mass 1. Class, is it making sense? Is it making sense? Is it making sense? Relax, questions will come soon. Alright, questions will come soon. Everyone must be carried along. I have to do all the explanations first before I start solving questions. Alright? So guys, can I move further now? Can I move further now? So you can see the form. I know I'm writing these things on the board. I know I'm writing it. So that when we start solving questions, no one will be left out. Alright? No one will be left out. So, because I will soon wipe all these things on the board, like all the formulas, so we can work everything. So ensure these formulas are in your notes, so we can start working on questions together. All right. So I think I am good to go. Question number 2. We have started with that one first. That first question we solved. So this one is question number 2. I'm going to wipe the board so we can start with question number next. All right. Question number next. I'm going to wipe the board. Can I do it now? Yeah, I can. Class, I want to wipe the board. Question time. Blessing time. Let us bless ourselves with these questions. So when you see them in exam, they'll be giveaway. They will be giveaway questions. They will be giveaway questions on this aspect. There's no how you find it difficult after watching this lesson. It is not possible. If you are here and you haven't yet subscribed to my YouTube channel, ensure you do that. Alright? Subscribe. Currently, I believe you are aware that we are over 100, we've got over 100,000 subscribers on YouTube. Alright? So I'm really excited. You can see this is my award. You get what I'm saying? I'm really excited. It's not easy to get this thing. It's really, I'm really excited for this thing. Alright. Alright, question time. So to you all who have been supporting, subscribing, I'm really happy and grateful. Alright. Thank you so much, my people. So, question 1 or question 2, anyone. So, this is my textbook, the chemistry masterpiece. If you are a student finding it difficult to understand chemistry calculations, like all these I've trashed, they are all inside, written by me. You can see my picture about the author and about the book. Alright, I wrote it, the chemistry masterpiece. You are a student finding it difficult, but don't worry, in my classes, there's no problem with chemistry, but you're going to gain more knowledge. Chemistry, here is it, the chemistry masterpiece. So for more information, do a direct message me, get my number, alright, for the chemistry masterpiece. Alright, question number 1, let me go and let's trash them together. Where are you? Where are you? Oh my God, where are you? Here in my book, I will wrote more than the formula. Okay, we are good, don't worry, we are good. Alright. Let us activate. Activation mood. Alright. So question 1, it says, given that the rate of diffusion, when you just see rate of diffusion in question I, you know that I is on grams. Alright, given that the rate of diffusion of a gas X, they do not tell us the name of the gas, they just say gas X, is 200 centimeter cube per everyone. When I started this class, what did they tell us about the unit for rate? Don't get me wrong. Given that the rate of diffusion of a gas is this value, what is the unit added to this number? Is it not the unit for rate? Centimeter cube per second. So remember all these. All right. Remember all these. Remember all these. All right. Let us move further. All right. So the question now says, what volume of X, meaning what volume of gas X will take, 1440 minutes. Alright, what volume of gas X will take 1440 minutes. 1440 minutes to diffuse. Don't worry, it's a cheap one. To diffuse through an orifice, which is through a hole, through an orifice. Alright, so let's work it out together. It's a cheap one, so let's solve it together. So this is the first question pertaining to what I have explained so far, what we have learned so far. Everyone, so you know I've given us a lot of formula, but this question is so cheap. How do we solve it? Everyone pay attention. They said, given that the rate, they gave us the rate of diffusion already. And the rate of this is a very straightforward question. The rate of diffusion of this gas X is this number, which is 200 centimeter cube per second. Are you there? Moving further. Question now says, what volume? That's the question. They are asking us to get volume. Everyone relax. What volume, alright, will take 1440 minutes? Anything that ends with minutes, is it not a time? Yes, now. So 1440 minutes is time. 1440 what, everyone? Minutes. And this is what? Time. And this is what? Time. So what do we do? What do we do, everyone? Listen now, this question requires us to use that third formula I gave to us that relates everyone watching me right now. Which formula did they tell us to relate rate, volume, and time? Have you forgotten? Is it not the formula that says the rate of a gas or rate of diffusion of gas is equal to that volume of the gas divided by time? Have you forgotten the formula I gave to us? Volume over time. Have you forgotten? Don't ever forget. Thank you so much. Somebody just got the answer. So rate will now be, okay, relax. What do we do? Everyone, what are we looking for? Are we not looking for volume? Let us make it subject of formula. So making volume subject, volume will now be very cheap. It will now be this times that. Class now, nobody should tell you this. Rate times time. Alright, that is volume. So rate times time. What is rate, everyone, according to our question? It was clearly stated, given that the rate of diffusion is this. Please write the unit as well. 200 centimeter cube per word, seconds. Now, times time, let me tell us something. Please, everybody listen. Ensure your time. Ensure your time is in seconds. Ensure your time is in seconds. convert. Don't ever use your time in minutes in any question. Convert it to seconds. How do you convert minutes to seconds? Very easy. How do you convert a value in minutes to seconds? Very cheap. You simply times that number in minutes times just 160. But if it was in hours, you times that number in hours times 260 times 60 times 60. For instance, it was in hours. So since it was in minutes, times you are just 160. So what happens here? What would then happen is 1440 minutes times just 160. That's 86,400. Alright? So what happens here is converting it. Alright? 1440 minutes. Alright, times just 160. So everything will now be, everybody time now will now be what? 86,400 seconds. That is what you have to write there for time. 86,000. Don't go and write it like that. Don't be fast and go and make mistake and write like that your exam. You fail the question. You fail it if you do it like that. Alright, put seconds at the back. You can want to do something right now. 400 seconds. Class, what then happens here? You know, mathematically, seconds will cancel seconds. Are you there? Remaining just centimeter cube. So what then happens is you say 200 times 86,000. 200 times 86,400 seconds. That's 7. That's volume will now be 17,280,000. What is the last unit? It's not a cm cube that is remaining after cancelling seconds. And what is the unit for volume? It's not centimeter cube in this aspect I told us. So the answer becomes 17,280,000 centimeter cube. Class, is it making sense to us? All right. Is it making sense to us? Is it making sense to us? Let me know in the comment section. So this one is for you now. It says the rate of diffusion is 150 and the time is now, let's say, 20 hours. Everybody work this one out for me. Provide this one in the comment section. Do that fast. All right. This is your own practice question. All right. This is your own practice question. Do that. Given that the rate of diffusion of gas X is that, what volume of X will take 20 seconds to diffuse? Let me go look at another question that relates to this thing I just solved. So we can move further. Alright, so we can move further, everyone. This question is so cheap. Alright, it is a very cheap one. Everybody pay attention, pay attention, listen, open your eyes and watch, because these things are so cheap. Alright. So class, can we move on now? I did get solved. So we can go back to the next question. All these questions are jam questions that jam have asked over the years, and more questions to be asked. Can I move on now? I believe everything is okay, right? So we can move on. So on the way to the board so I can solve more practice questions. Alright? Good. I love you guys. I love you all. You guys are doing so well. I'm proud of you guys. Proud of everyone here. So another one, jam up asked. Another one, jam up asked. That's what I'm going to bring next. Another one, jam asked. Another one, jam asked. Jam. Another one, that body asked. Everyone, pay attention. Everyone, pay attention. So this is another question. All right. This is another one jam asked. It says, this one is much more simpler. It says 480 centimeter cube of a certain gas of a certain gas diffuses. Diffuses through a porous partition. It's not that word porous is not big. Don't be scared of the word porous. So that you see porous partition, you'll be scared. Don't be porous is something that has hole. You understand? They can also say porous pot. Alright? Oh my god. Class, is the network okay? Let me know in the comment section. If the network is okay, let me know in the comment section if the network is okay. Let me know in the comment section. Let me know because I just said network. Please don't scare us. Alright? The thing is clear here. Network is so clear here. At my end is really, really clear. Alright, so don't scare us. Network is okay. Alright? Alright. Porous partition meaning porous, something that has hole. The gases are diffusing, moving out of the pot or stuff like that. Alright? Porous partition in 2 minutes. In 2 minutes. Alright? In 2 what minutes? So cheap question. The question now says, what is the rate of diffusion of that gas? What is the rate of diffusion of the gas? Alright, so cheap. Let me write the options quickly. Before I don't solve, I believe some of us should have solved the question. So A says 40 centimeter cube per seconds. Option B says 4 centimeter cube per seconds. Quickly. Option C says quickly solve. It's very cheap. It's exactly almost like one we just saw. Just this time around, you're looking for rates, you're not looking for volume. They gave you volume already. 240 centimeter cube per seconds. And option D, it is a 24 centimeter cube per watt seconds, everyone. So what do we do? So first of all, the question says, what is the rate of diffusion? Them asking me for rate of diffusion, I didn't know what, and they gave me volume, they gave me time. So when they are asking us for rate of diffusion, how does rate relate to volume and time? Is it not by the formula which says volume divided by time? Have you forgotten? Have you forgotten? Don't do that. So rate will now be equal to, what is my volume? 480 centimeter cube all over time. Please, don't forget. Always ensure your time is converted to what? Seconds. How do you convert 2 minutes to seconds times by what? 60, just one. Alright? So it's going to be 2 times what? 60, and that is 120. Alright? Automatically the time becomes 120 what? Seconds. Class, hope it's making sense now. I've done that. I had 120 what? Seconds. So what do we do, everybody? Divide. Alright, divide. So 480 divided by 120, that's 4. Alright, that's 4. The unit remains 4 centimeter cube per watt second. So this is the answer. So you look for the option that has this. So let's check together. Is it A? No. Is it B? Yeah, it is B. B says 4 centimeter cube per watt seconds. It's a very cheap one. Jam chemistry, you will trash it. You are going to trash it. Jam chemistry, you are going to trash it. Other exam chemistry, you are going to trash it. These are all you need. This thing, this topic, I'm going to trash it in the course of this class lesson. So get ready. Get ready. Get ready. Alright. Question number next. Can I wipe the board? Can I wipe the board so we can trash other questions? You can see we are solving questions pertaining to just this formula now. We'll soon migrate. We'll soon move. Class, can I wipe the board? Let me know in the comment section. Let me know in the comment section if I can wipe the board. Alright. Ensure you subscribe to my channel. Alright, subscribe to my YouTube channel. If you are here, subscribe. Alright, very essential. So question number next. Let us work them together. Let us work them. I have a lot of them here. I'm going to trash them. All right. All right. Good one. Okay, guys. Another one. Another question. Another question. Another one. Another one. It says, everyone listen. Everyone listen. Let me write this question on the board. This question I'm about writing, it is not on this formula we just solved. Please. This question I'm about solving on the board, it is a question on another area. You know, we have derived all the formulas, right? But it's so cheap. All right, let's do it together. So I'll write the question first. It says 200 centimeter cube of oxygen gas. I beg you, name of God, guys, please listen. No noise. Are you making noise? How will I believe you're making noise? I don't even know, but no problem. All that matters is that you are listening. All right, 200 centimeter cube of oxygen gas diffuses. Everyone pay attention. No, this one don't open your eyes, but if you can solve this, there's no question on this side you cannot solve. Just listen. Diffuses or diffuse through a porous pot, meaning a pot we hold. A porous, okay, plug. Alright, they call it plug, a porous plug. In 50 seconds. Everyone pay attention. In 50 seconds, pay attention. So then I say something. And how long will, alright, how long? Take note of this thing. Let me write the question. I'll repeat this matter. How long will 80 centimeter cube of methane gas, how long will 80 centimeter cube of methane gas take to diffuse through same porous plug under same condition. Everyone pay attention. Everyone pay attention. First of all, let me refill this marker so I can trash it for us. It's a very cheap one, but you have to be very smart. All right, you have to be very, very smart. You have to be very, very smart, guys. All right, so I want you guys to please listen to how I'm going to solve this question right now. Listen to how this question will be solved. Listen to how this question will be solved and tackled. Everyone, don't listen. It's a very cheap one. First of all, we have to bring out the informations in this question that will basically tell us the formula to use to solve it. You can see I'm saying these things so that it will be ringing inside your head to tell you that, oh, you have to be very smart. You don't have to rush when solving. Take your time and understand things very well. All right, take your time and understand things very well. I repeat, we read the question well and know what exactly is given to us and know what exactly of the formula to use. I've derived a lot of formulas and it's a very cheap one. Everyone, let us solve together. Everyone, let us solve together. First, I'll write the options the way it is in the jam. All right. Class, let me know if the network is okay. Is the network okay? Class, is the network okay? Let me know in the comment section. Is the network okay? Let me know in the comment section. Is the network okay? Let me know in the comment section. Please, you guys should not scare me because someone just said network again. Is the network okay? Is the network okay? All right. So option A says 40 seconds. Option B says 20 seconds. Option C says 14 seconds. Option D says 7 seconds. It's so cheap. Everyone pay attention. It's a cheap one. Everyone listen well. Listen. Let's sum it together. First of all, see, the formula I'm going to use to solve this question I've given us already. So as a student, to read your question well, it says 200 centimeter cube of oxygen gas. Everyone, oxygen gas, what is the symbol? It is O2. Are you aware? You don't know it before, know it from today. This oxygen gas is O2. Anything that is a gas, most times they are diatomic. O2. First, another, methane gas. Methane, as a student in organic chemistry, is CH4. Are you listening? I know I'm saying all this. Listen. Open your eyes and watch to which the way we are going to trash this question together. Everyone, listen well. So at first, remember I said, bring out your information first, so we now know the formula to use. 200 centimeter cube of oxygen gas. So first of all, we have two sets of gases. Oxygen gas was the first set of gas. Alright, to write it up. Oxygen what? Gas. After writing oxygen gas, I will then draw a line to differentiate it from the next gas, which is okay, oxygen gas, everybody agree that is O2, right? And next gas, which is what? Methane gas. Methane is an alkane. Alright, you know what I'm talking about in organic chemistry. And methane is CH4. Everyone. So I saw, they now told me something about oxygen gas. They said 200 centimeter cube of oxygen gas. 200 centimeter cube of oxygen gas, everybody. 200 centimeter cube of oxygen gas, listen, is the first 200, it's not the first volume you saw in the question. Yes, it is. Hence, that becomes my V1. Everyone pay attention. So automatically this is my V1. And who has that volume? Which gas? Is it oxygen gas or methane gas? Oxygen gas. Pay attention. Remember I said, write all these things out so that you know exactly the formula to use. Alright? 200 centimeter cube of oxygen gas diffused through a porous plug in 50 seconds. So what was the time it took this gas to diffuse? That is the first time we saw in the question. And it was what, everyone? 50 what seconds. Everyone pay attention. Full stop. Then another one that came. Before we move on, everybody, did they not give us the gas? Hell, they gave us. So from the gas given to us, we can simply get our molecular mass. Everyone, I repeat, from the gas given to us, we can get our molecular mass. I taught us stoichiometry now. You know all these things. First of all, what is the atomic mass of oxygen? It is 16. What is the atomic mass of carbon? It is 12. What about hydrogen atomic mass? 1. I know I'm saying all this. So with all this said, let us solve the molecular mass for this gas together. Everyone pay attention. Alright, molecular mass, and it is the first. Is this not the first gas mentioned? Hence, this will not be M1, like molecular mass 1 now. Class, is it making sense? Will not be equal to everybody listen. Everyone listen. Listen. Remember I said from the gas given to you, you can get your molecular mass. And what's the gas? Is it not O2? So oxygen atomic mass, is it not 16? But how many opportunities do we have? How many opportunities do we have? We have 12. So it's going to be what, everybody? 32 what? Gram per mole. Remember, the unit for molar mass is gram per mole. So hence, the molecular mass of the first gas seen. Why did I call it molecular mass? Because it is for the first gas. It is for what the first gas mentioned, oxygen gas. So it's 32 gram per mole. So let us move further. Then I said, how long? What does how long is? How long is time? How long is everybody? Is what, everybody? Time now. Anything that is how long is what? Time. So how long now? How long? All right. How long? Will. So how long now? Will 80 Oh my God, 80. Everybody listen. How long will 80? So, 80 now, 80. Is it not 80 centimeters? It's not the second volume we saw. The first one we saw was 400. So, the next one you're going to see is the second. So, V2, automatically is V2, and it's what 80 centimeters cube. For which gas everybody is, not methane gas. And they're asking us for how long, that's times 2 now. Yes. How long? Times 2, and it's going to be what now? What we are looking for, everybody. Are you listening? Class, are you following me? So how do I get our molecular mass very cheap? We now simply come here. Carbon is 12. Because from the methane, we still get our molecular mass. We are done with carbon plus. Hope you not get molecular mass now. Plus hydrogen atomic mass is 1. But how many of I need to have 4? 4 times 4. So when we start to what are we getting? What are we getting, everybody? We're going to get what now? That 12 plus what? 12 plus 4, that is 16 gram per mole. Class, are you following me? So basically, the molecular mass or the molar mass of methane gas is 16 gram per mole. Alright, we got 12 plus 1 times 4, that is 16. Alright, and the other one is 16 times 2, that is what? 32. Alright, so you can see what we have established. And this one now, who are this Who has it? Is it not molecular mass 2? Is it not for the second gas? Yes, it is. Everyone without wasting time. Alright, everyone without wasting time. I repeat, everyone without wasting time. Let's solve together. So everybody, based on the information brought out, alright, listen. Alright, you can see now in this question we are relating 3 important information. What are they? Volume, time, and molecular mass. Go down to the second gas, methane. Methane gas, volume, time, and molecular mass. Everybody, based on the formulas I gave to us, which formula relates volume, time, and molecular mass? Which formula relates volume, don't from my hand, time, and molecular mass together? Which formula relates those guys? Now they are not hard. Which formula relates them together? Everyone, which formula relates them together? Is it not volume 1? Divided everybody now, do everyone over B2 times what now? T2 over T1. Are you there? Hope you are aware that I can start to remove these times and just write them together. It still means times. Alright? Okay, is equal to roots of what now? Hope you guys are following me. Alright, molecular mass. Molecular mass what? 2 divided by molecular mass. What, everybody? 1. Let's solve together. What are we looking for? Everybody shine your eyes. We are looking for the time it will take methane gas to diffuse. How long will 80 centimeters of methane gas diffuse through the same porous block under same condition? How long? So we are looking for what time? Time 2 now. Time for the second gas. So we are looking for time 2. Let us input our parameter. Volume 1 was 200. So 200 times, I can say it was centimeter cube, but let's just write 200, alright, times what we are looking for, T2, all divided by what is volume 2. Everyone, what is volume 2? 80, alright, 80 centimeter cube, times what is time 1. The time it took the first gas to diffuse is 50 seconds, alright, 50, alright, is equal to root of what? What is molecular mass 2? Is it 32 or 16? Must be wise. Is it molecular mass 2? Is it 32 or 16? Everybody, don't make it. It is 16, molecular mass 2. Is it not for the second gas? It is 16. Alright, it is what? 16. It is what? 16. Molecular mass 2 for the second gas is 16. Don't want me. Students make mistake a lot. They go quiz one first because that's a problem. Don't do that. Don't make that mistake. Don't make it. But I know that most persons want to make the mistake. Don't make it. I'm not put that too well. So you're seeing it. Is it not true? You're seeing no. Write the second guy first. Alright? I know some persons I won't add something might make that mistake or correct yourself. Correct yourself. Alright? Molecular mass 1 now, which is what 32. Class, are you following me? So you know you can solve this thing without the use of the calculator. Definitely you can solve it. So you not think 16 divided by 32, what is that? That is 1/2. Are you aware? You know, you can break this guy. The lowest it gives you is 1/2. Are you aware? Let us work it out together. Alright? Alright. Okay, you know what? Let me just quickly, you can solve it without the use of the calculator. Very, very possible. Alright? Well, let's work it. 16 divided by 32. That is 1/2. Everybody, because there is no space now, I want to quickly do something. Don't say you don't understand. 16/32, 1/2. Let me rewrite it because I have to just rewrite it. 200 times T2 divided by 80 times 50 is equal to root of 1/2. Class, is it understood? What I just did the other, I broke it. So square roots now, square root of 1/2, what's it? Square root of 1/2. Let me come here and finish it. Everybody, I want to come here and finish the calculation. I want to come here. I want to rewrite again 200. Everybody times T2 divided by 80 times 50 is equal to square root of this is 0.71. Class, are you following me? Don't make mistake. Go. So you know what? How do you make your T2? It's possible to make it something. You say divided by 1 and cross multiply. Making this subject T2 will now be equal to what? Times this one first now. You know what I'm talking about. You want to make this as something. You want to make this into something times everything up here. So it's going to be 80 times 50 times 0.71. All divided by what is remaining, which is what? 200 times what? 1. Yes, now. So everybody, what becomes T2? Let's not rush you. So I want to write 80 times 50 times 0.7, all divided by 200 times 1. That is 14. That is what? 14. Alright, that is 14. That is what, everybody? 14 seconds. That is what, everyone? 14 seconds. That is what, everyone? 14 seconds. That is what, everyone? 14. I repeat. 16. See, divide this one first without the square root. Do it. 16/32. That is 1/2. I have to bring it down. So I now squared 1 divided by 2. Square root of 1/2. What is that? 0.71. Class, is it making sense to us? Class, is it making sense to us? Let me know in the comment section. Let me know in the comment section. Let me know in the comment section if this is making sense to us. This question, we have trashed it already. Alright, it's a very cheap one. We have trashed it already. It is a very cheap one. Let me know in the comment section. Let me know in the comment section. Let me know in the comment section if this question is making sense to us. Alright, let me know in the comment section if it's making sense to us. The way it was solved, is it understood? You all should let me know. Let me know in the comment section. Alright, my own is, see, following, then don't rush, oh. Don't rush. When you are doing things, don't what? Rush. Don't rush. Alright? Don't rush when you're solving. Don't rush when you're solving. What do you call, I am the king of sounds. No, what you did is wrong. How will you say 0.5 is 0.25? Are they, two of them, they don't relate now. How will you say they don't relate? Definitely, 1/2 is 0.5. 1/2 is what? 0.5. I'm aware about that. Do you understand? 1/2 is 0.5. But what does this say? Square it. Square root of 1/2 is what? Or just a square root of 0.5. Do it your calculator, sharp. Look at it now. If you want to use 0.5, all right? Look at it now. What are you saying? Look at it. 0.7. And now I have to approximate that 7 to that 0. Making it what? 0. What? 1. 0.71. Are you there? So what are we saying now? What are we saying? Definitely 1/2. 1/2. Look at it. 1/2. 1/2 is what do you call it now? Let me change it to the decimal. Look at it. 1/2 is 0.5. 1/2 is 0.1/2 is 0.5. So where is this 0.25 coming from? All right, no problem. Class, is it making sense right now? So we have 14 seconds. Answer becomes obvious. Don't rush, oh. Don't rush. Don't rush when you're solving. Practice makes perfect, right? Practice makes perfect. Can I wipe the board down? Can I wipe the board, everyone? Can I wipe the board so we can trash more? Can I wipe the board so we can move further? So I want to basically bring another one that is similar to this. Remember, we're trashing a lot of them tonight, all right? So I want to wipe. Can I wipe? Can I wipe? Yeah, I can. Can I wipe? Yeah, I can. And you can't waste. Can I wipe? Screenshot quickly. Screenshot quickly. Screenshot. No time. Everyone, pay attention. Pay attention. You have to know what you are doing. That is what me I'm interested in. I saw with clarity. I saw with clarity. Anything I do it to be very, I make it so to be very clear, so that nobody will be left out. Do you understand what I'm saying? So please, everyone, open your eyes and there. Don't be weak. Don't be tired. Do you understand? Don't be weak. And don't be tired. Do you understand? We'll get there. We all will get there. Alright? I've done my own already. But it's your turn to get it. Do you understand? I've gotten mine already. I've graduated. I'm already registered nurse, registered midwife from the University of Benin. And this is your time to get it as well. For those who are studying nursing in the university, those federal universities and the rest. So it's your time. You can do it as well. Do you understand? So let's trash more questions. Let us trash more questions. I want to bring another one. I want to bring another one here. I want to bring another one. Let's see how it goes. All right. So here is another question. This one is so sweet and easy. Similar, exactly similar to this one we just saw. But you must pay attention, everybody. It says, if 465 centimeter cube of SO2 gas, sulfur oxide, alright, can diffuse, alright, can diffuse, can what everybody? Diffuse through a partition. Relax in 30 seconds. My point is, bring out the parameters first. Bring out the parameters, don't rush. Bring out the parameters first. That's all I'm interested in. Bring out your parameters in 30 seconds. So question now says, how long? You see how long, you know what that means, right? How long? That is time. The actual time. How long will an equal be smart? Will an equal, they did not mention the volume, this is a key term. Will an equal volume of hydrogen sulfide, H2S, right? Hydrogen sulfide, H2S diffuse, hydrogen sulfide, H2S diffuse through same partition, through same word partition. Everyone pay attention. Alright, so basically here is sulfur is 32 atomic mass, oxygen is 16 atomic mass, hydrogen is 1 atomic mass. Because these are the elements involved. There's another sulfur here, or sulfur is sulfur everywhere. Alright, so everybody, let us work out these one together. Alright, let us work out these one together. Alright, let us work out this one together right now. Let us work out this one right now. I believe you are aware that this hydrogen sulfide mentioned here is a gas. And it is a colorless gas. Alright, it has a rotten egg smell. And it is acidic in nature. Hope you are aware about that. Alright, hope you are aware about that. Alright, on the test for this guy, it turns lead ethanoic paper black. It is colorless, it has a rotten smell, and it is acidic in nature. Alright? So that is for that. Let's talk together. So they said, everybody, there are two gases here. Sulfur oxide and hydrogen what? Sulfide. Now pay attention. So the first gas, they said if 465 centimeters of sulfur oxide. So the first volume I'm seeing here is 465 centimeter what? Cube of what? Sulfur oxide. Alright? So everybody, this one is for what? SO2. Alright, pay attention. So if 465 centimeters of SO2 can diffuse, so this is the first volume I saw, it becomes a Q1, can diffuse through a partition in 10 seconds. In 30 seconds. That's the time one. That's the first time I saw. Class, pay attention, 30 seconds. Are you there? So automatically we are done. Then I said, how long? So let's just say that. How long? So basically we are done with this. So let's get into the next task. How long? How long? Time 2. That's what we're looking for. How long will an equal? How long will an equal volume? So it means that this gas has the same volume as this gas. Are you there? So basically V2 will be the same as this gas. Class, are you there? I can't see how cheap this question is. It's so cheap. How long will an equal volume of this gas? So basically they have the same volume now, equal volume. Alright, and what is the gas? Hydrogen or sulfide. So without wasting time, everybody, let's calculate the molar masses. So MM, you know, C is for the first gas, MM1 is for the first gas, so SO2. Now let's work it out together. SO2, sulfur is 32 atomic mass, plus oxygen 16. How many do you have? Times 2. Now we can calculate what we have 36. What becomes everything? 64 grams per mole. Are you aware? Class, are you aware? Are you aware about that? Class, are you aware? Let me know. So let's quickly do this. Molecular mass what? This for the second gas, so it's going to be a 2. So hydrogen is 1 atomic mass, but we have 2 of it times 2. Plus sulfur atomic mass 32. Class, hope this is making sense, right? So when you are calculating, we get 34 gram per mole. Are you there? What next do we do? What next do we do? What next do we do, everybody? Let's basically now, if you check, what are the formulas these parameters are relating? Relating volume, time, and molecular mass. Volume, time, and molecular mass. Volume, time, and molecular mass. So what formula relates volume? The same question we just saw. Volume, time, and what molecular mass. Everybody, what formula relates them? We've worked on this too many times. It is volume 1 divided by volume 2 times what? T2 divided by time what? 1 is equal to all roots of what? The molecular mass 2 over what, everybody? Molecular mass 1. Are you there? What next do we do? Don't rush. What is volume 1? 465. So under volume 1, alright, 465 centimeter cube times. What is time 2? What is time? Time 2 is what we are looking for. So here it becomes T2 divided by what is volume 2? Equal volume. Equal. So automatically it becomes 465 as well. Times what is time 1? 30 seconds. Here becomes 30 seconds divided by all square root of everybody. What should I write here? Don't go and make mistake and put everyone up there. Oh, you make it. It's a big problem. Oh, alright. M2 is 34 all over M1 worth 64. Class, are you there? 64 gram per mole. Alright. Automatically, I believe you are aware that this one will cancel this one. So basically, if they have equal volume, the volume will not go away. This question automatically will not relate just to parameter. Yes, the volume will not vanish away because they are equal. It now relates time and molecular mass. Yeah, for sure. I can just try to remove this volume. Do you understand? I will just, if that's you have to be smart as a student. Do you understand what I just did, everybody? Do you understand what I just did? Alright? Are you guys following me? You can say I can try to just remove volume because they are equal in this case. But other case where they are not equal, we cannot remove them. So let's talk together. What's the remaining? Everybody, let's tackle it together. Don't rush. 34 divided by, is it 34? Let me do something again. 1 times 2 plus 32. You know, my own is, I know it's 34, but I have to press calculator just to be sure. Alright, know that you understand, just be sure. Only declare exam. It's just, if you click anything that day, don't be fast. Don't be like Merlin. Don't be like Merlin. No, don't be like Merlin. You are not Merlin. Do you understand? Don't be like Merlin. You're not Merlin right now. Exam, you don't do like Merlin. Solve it clear. Know what you are doing before you choose options. I know it and little thing can just make you feel the question. So 34 divided by 64, that is a 0. Look at what I've done. 0.5, what do you call it now? 0.53, okay, let's take it together. So here is 30, 2 over 30 is equal to, alright, just pay attention, roots. Everybody, when I did 34 over 64, I had 0.53125. Are you there? So square root of this number 0.53125. I had 0. When I squared through this value, look at what I had, everybody. Look at what I got. T2 will now be over 30 is equal to 0.73. This is what I got. When I scored, be very, very careful. Don't make me say T2 will now be what, everyone? Tell me now. 30 times 0.7173 divided by 1 divided by nothing now. You understand what I'm saying? So T2 will now be what, divided by 1 divided by nothing. Okay, divided by 1. No problem. So 30 times 30. Alright? 30 times 0.73, that is 21.9 seconds. So the time it will take the second class H2S to diffuse is 29.1 seconds, which is approximately 22 seconds. Alright? Alright, which is what approximately what 22 seconds. Which approximately 22 what seconds. You can see how simple this one is. Very cheap, not difficult at all. Jam chemistry? No now. They don't fail it too. They don't do it too. You don't do that. They don't need to fail chemistry in jam. Don't do that too. Chemistry in jam. Don't fail it too. You're not trying to fail it too. It is 90 and above. They don't get 80. If you do 80, it's not a good one. It's not a good one. Don't do that. No, they don't get 80 in jam chemistry. Alright? You don't do that, guys. I know what I'm talking about. It's so cheap to get it. It's so cheap to get so high. It's very high score in this subject. Alright, another question. Can I wipe the board? Yeah, I can. Can I wipe the board? Yeah, I can. Can I wipe the board? Yeah, I can. So let us move on into more questions on this aspect. They are not hard. Practice makes what? Perfect. Practice makes perfect, guys. Practice makes perfect. Practice makes what? Perfect. So let me bring more questions pertaining to this aspect. Jam I've asked so far. Alright? Let me bring another one. Let's see how smart we are. This one is so cheap. Everyone, this is for you, it's not for me. I'm not going to solve this. I've taught us many times, so solve it for me. If 30 centimeter cube of oxygen. They did not write the symbol, they just spelled it. Whenever you say it like a gas, always put 2 in the front, most times. Oxygen gas, that's it. Alright? If 30 centimeter of oxygen gas diffuses, this for you all, diffuses through a porous plug in 7 seconds. Alright? Full stop. How long will it take? Alright. How long again? Is a jump. How long? They left it up. How long will it take? Will it take an equal? No, not an equal. How long will it take now? 60. It's not equal to volume, it's 60. 60. Alright, 60. Where are you? 60 centimeter cube of. Now this time around they wrote chlorine gas. They do not write the same, but I just write for you so that you know it that chlorine gas, anything most times Cl2 is the elements I put 2 most times. Chlorine gas to diffuse. Everybody, this for you, solve it and put the answer in the comments. Don't rush through same parts, through same plug. Alright, so option A. Should I do this one for us? No, nah. No, nah. I'm not going to do this because you are the one writing the exam. Alright? So you have to walk so that you'll be able to trash all these things that don't have. C now says 21 seconds. C says 21 seconds. And D says 30 seconds. Let's see what we can do and provide the answer in the comment section. Alright, let's see what we can do and provide the answer. I'm sure you provide the correct answer. Oh my God. People, I just left the board. People already provide the answer. Please, let's solve it well. Let's solve it well. Let's solve it well. Let us solve it well. Let us solve it well. Let us solve it well. Alright? Let us solve it what? Well. Alright? Let us solve it well. Let us solve it well. Solve it well, though. So, just solve. I'm coming in a few minutes so we can continue. All right? I believe we all have solved the question, right? I believe we have solved the question. Good one. Good one. So I'll wipe the board so we can trash all the questions pertaining to these aspects that are very, very important. They are very, very essential. They are very, very essential. Alright guys, let's get into more practice questions on this aspect, alright? At least this one I gave the rest, I've solved like 2 questions on them, so this is the third one. So let's get into other areas to which our questions can be asked on this aspect based on the formulas we have derived so far, alright? So you all should get ready. You all should get ready. So where are you? Where is this question? Someone of them just now. So one of the questions just now. Alright, look at it. Let's work this one together. Question number 6 here. It says, if 100 centimeter cube, everybody pay attention, of oxygen gas O2, they spelled it if we have to write like this, so that we know what I do quickly. Pass. Maybe was pass. Let's write pass through. Or you pass through a porous is something we hold. Porous plug. Alright. In 50 seconds. Everybody is 50 seconds, eh? So So full stop continuation. The time, everyone listen. The time taking for the same, be wise, very smart. The time taken for the same volume of hydrogen gas to pass. The same question actually based on what we have said. Through the same porous plug is option A 10 seconds, option B 12.5 seconds, option C 17.5 seconds, option D 32.0 seconds. Alright, this is a 1992 JAM class question. It's very cheap. This one, I'm not going to solve it as well, because when writing it, I saw that it's exactly. You know, normally they've been saying, how long? They just made it clear, the time taken for the same volume. So definitely, let me help. Volume 1 is 100 centimeter cube. And who has it? Oxygen gas. So, and they say it passed for time 1, same oxygen gas, 50 watt seconds. Alright? So basically, what the time taken, meaning time 2 is what we're looking for. For the same volume, automatically V2 will have the same watt 100. And you there, both of them will have the same watt volume. Alright, the time taken for the same volume of which gas? Hydrogen gas to diffuse. You know, oxygen atomic mass is 32. Oh. The previous one, is it not for chlorine? Oh my god, sorry. Chlorine atomic mass is 35.5. For those who have not yet solved the question. So that don't be a problem. Chlorine atomic mass is 35.5. Sorry about that. Alright, so I told you to give me the atomic mass, but I believe you've gotten it, right? Chlorine atomic mass is 35.5. For that, I shall just find. Alright? So now hydrogen is what 1. I believe you can tackle this. Tackle this, I'm not going to solve, because I've done it already. Tackle it yourself. Everybody do it. Do it and write the answer in the comment section so I can wipe the board. So we can go over more areas. Alright. Alright. Good one. Let us move further. You guys are doing well. I'm proud of you guys. Alright. I'm proud of you all. Now, this next question on the right is different from what we've been doing since. It is different but so cheap. Different but so easy. So watch closely. As I wipe this one on the board, watch closely as I solve this. Watch closely. A jam question. I want to wipe the board so we can move forward. Can I wipe the board? Yeah, I can. There is no time. So this one is so cheap, very cheap, like ABCD, very cheap, like A, B, C, D. So just listen and pay attention. Listen and pay attention to this question on the right next. It's so easy. People will be like scared of it, but it's so cheap. We have worked on everything already. Everybody look at it. It says, if SO2 gas and methane gas are released. Okay, they released both gases simultaneously. They release them together. Alright, at the opposite end of a narrow tube. It is not a big statement, just listen. Now, the question now says the rate of diffusion. The rate of diffusion of the SO2 gas and the rate of diffusion of methane gas. They said the rate of diffusion, the arrow S, arrow SO2 and arrow CH4, meaning arrow is the rate of diffusion of this and the rate of diffusion of the other gas, methane gas, will be in the ratio what? So cheap. Pay attention. A, 4:1. B, 2:1, C 1:2, D 1:4. Let's work it out together because it's a very simple question. It is a very simple question. Everybody look at, see, look at it now. Both gases are released simultaneously. Everybody, is it not? Did you see density here? Don't for my hand. Did you see density here? No, now. So basically, you're still going to use the formula that relates rate of diffusion with, you know, what can you get from this compound? It's not molecular mass. So use that your first formula that says rate 1, all right, rate 1 over rate 2 is equal to square root of what? Molecular mass mm2 over, this is what I'm going to use to solve this question. Why? Because I know you're saying, okay, why not use density? I cannot use density because the questions will be solving if they don't measure density. We'll get there. Do you understand? But basically, look at rate 1. Who is the rate 1? It's for the first gas elimination. So automatically rate 1 is SO2 gas. Class, are you there? Rate 1 is for which gas? SO2 what? Gas. Rate 2 is for which gas? Methane what? Gas. Are you listening? Then I said, okay, if SO2 and methane are released simultaneously at the opposite end of a tube, of a narrow tube, the rate of diffusion will not be in the ratio. Very simple. First of all, get their molecular masses. What is the molecular mass for this SO2 gas? Simple now. Sulfur is 32, oxygen is 16. Hope you are aware. We've said this thing anywhere. Times 2, and molecular mass for this gas will not be worth 64 grams per mole. Everybody. So basically, who now have 1? SO2. Don't make mistake. Who now have 2? Do you understand what I'm saying? Alright. So automatically the molecular mass of this 2 is for SO2 now. Who is now molecular? No, sorry. SO2. So here should be 1. Do you understand what I'm saying? You can know I paused so that you know that what I wrote initially. So you know that's serious. Don't make mistake for your exam. So then Mn2. You see H4, let's calculate it now. Yes, there is second gas station and molecular mass 2 gas, second gas station. You can't get 2. Alright, here's 12 plus 1 times 4. Class, look, I'm not fast. Alright, 1 times 4. We have established all this fact before. That's why we 1 times 4. Alright, so molecular mass 2 will now be equal to what now? 16 grams per mole. So everybody, let's basically do something. So rate 1, which is for SO2 gas, over rate 2, which is for CH4 gas, will now be equal to square root of what was molecular mass 2? Is molecular mass 2? Methane now. So you now be 16 divided by yes now. See there, what is molecular mass 1? Remember I look for ratio. Here's what? 64. Everybody 16 over 64 first. Alright, 16 over 64. 16 over 64, what is that? That's everyone. See, don't make mistake. Oh, I know what I'm saying. I want to continue here. Everybody watch. Rate 1, which is for SO2 gas, over rate 2, which is for CH4 gas, is equal to what now? I did not press my calculator root of 16 over 64. I just pressed 16 over 64. Everybody look at calculator. Look at 60 over 64. 1 over 4. So here will now be what? 1 over 4. Are you listening? So what next? I just evaluated this. Give me 1 over 4. So what next will I do? Now say square root of what? 1 divided by 4. Look at what I got. Square root of 1 divided by 4. Everybody look at. See, square root of 1, what's that? 1 over 2. 1 over what? 2. 1 over 2. 1 over 2. 1 over 2. So basically, breaking this more, writing it here, rate 1 for the SO2 gas over rate 2 for the CH4 gas will now be 1 over 4. Hence, their ratio will now be 1:2. Everybody, 1:2. Is it 2 ratio? Is it 2 ratio? What we got? Don't make mistake. Answer is C. Don't stress yourself. Answer to the question is C. Class. Don't make mistake, oh. I wrote on over 4. So people just go and rush a big D. Don't make mistake, oh. You make mistake. You can see what I'm saying. Some people forgot square root. You can see what I'm saying. Somebody forgets square root. He forgot left square root in the house. He left square root in the house. He did not go with square root. Why would you do that? Next time, don't make that mistake. Are you listening? Don't make that mistake next time. It's a big problem. All right? All right? Don't worry, eh? We are going somewhere. Class, does it make sense to everyone? So the answer is 1:2. Not 2:1, or even 1:4. It's not this, so you can see that I showed you my calculator. So don't make mistake. We don't make mistake here. We don't do that. We don't make mistake. Right? As far as chemistry is concerned, they don't make them. Do you understand? So that is for that. So on the whiteboard, so I can solve more questions. All right? Yes. All right. All right. Can I wipe the board? I believe I can wipe the board right now. Class. All right. Another question on what we have learned so far. That's we have solved a lot of them. We have solved a lot. All right. So I give you a volume of methane gas. I think it's how long. I have still seen another long question. Those are cheap now. Give away. No need to write on the board again. No need. All right. No need to write those ones on the board again. Everybody. No need. I'm not going to write it on the board. All right. I've seen another one. This one is a theoretical one, but simple. It says, which of the following gases, it's a very popular question in my single exam, will diffuse? Which of the following gases will diffuse fastest? Cheap. When passed through a porous plug. Everyone, pay attention. Now, relax. Option A says propane gas. Very cheap one. Option B says oxygen gas. So easy. Option C says methane gas. Option D says ammonia gas. Everyone pay attention. Alright, now, how do you know the gas that will move faster, that will run faster? How do you know the gas that will be like more, that will be faster, fast, like a flash? The gas that will be fastest is the gas with the lesser mass. Are you listening? The gas that will move fastest will be the gas, somebody that's thin. That's somebody that's fat. Most times, somebody that's thin and has muscles. Not like he's not fat. Like somebody that is just average and has muscle. He basically runs faster than somebody that's fat, very like obese, like obesity. Do you understand what I'm saying? So basically, the gas that is lowest in mass. The mass we are talking about here is molecular mass. Everybody, as a student, what is propane gas? What is methane gas? Propane and methane, where are they from? Are they not alkanes? Let us quickly work on organic chemistry. You know I've worked on organic chemistry already. The 7 hours, 35 minutes plus lecture on organic chemistry. Work on all these things. 7 hours lecture plus in organic chemistry. All this is trash on it. Remember, what is the general formula for the alkane? Don't forget, CnH2n plus what? Plus what? 2, right? And in organic chemistry, a compound that is prop means that compound has 3 carbon. A compound that is met, it means that it has 1 carbon. So where we have N, we put those numbers of carbon. So let's get for propane first. Let us get the chemical formula for propane. So basically, since it has 3 carbon, C3H, what? You are a student, you have not watched my lesson. 7 hours lesson, plus in organic chemistry, full lecture, beginning to end. You are still here. I beg in the name of God, go and watch it to save yourself. Alright? From that aspect of organic chemistry, because we've trashed organic chemistry already. Alright? So, into, what is N again? 3 plus 2. So everything becomes C3, what? H, what? 6 plus 2. Everything becomes what? C3H, what? 8. So C3H8 is actually propane. Alright? C3H8 is propane. Remember, carbon atomic mass is 12. Hydrogen atomic mass is 1. I am coming. So propane is C3H8. You can draw the structure quickly. It's not hard. 3 carbon, 6 is a single bonded compound. So put all your, carbon is tetravalent. Go and watch my lesson on organic chemistry, beginning to end, full lecture. Alright, put your 8 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. This will tell you that this is actually correct. Because all the carbons are completely filled. They are all tetravalent in all the positions. Alright, so C3H4, C3H8 is the chemical formula for what now? Alright, C3H4 is the chemical formula for what? Propane. Alright. What about oxygen gas? What it meant is that O2. So these are oxygen gases, so it doesn't change. Oxygen gas does not change. Alright? Oxygen gas does not change. Methane gas, they should not tell you it is H4, but we can check it, it's correct. Ammonia as a student is NH3, don't forget. So the one with the lowest mass will diffuse faster. Let's calculate the molecular mass here. So quickly, no time to waste in our class. Molecular mass quickly, molecular mass quickly. 12 times 3 plus 1 times 8 is equal to, class, are you aware? This is another now. Oxygen molecular mass, O2, molecular mass, oxygen 16 times 2 is equal to, let's do such quickly, molecular mass, 12 plus 1 times 4, quickly. Class, here, molecular mass, nitrogen, the atomic mass is 14, you don't know it from today. 14 plus hydrogen 1 times 3 equal to, class, which one has the lowest mass? The one with the lowest mass will run faster, will diffuse faster, alright? Diffuse what faster, so calculate quickly. Tell me the one with the lowest. So here 12 times 3 plus 8, that's 44 grams per mole. Alright, 44 grams per mole, that's the unit of molecular mass. Alright, here is 16 times 2, that's 32 grams per mole. Alright, here is what? 12 plus 1 times 4, that is 16 grams per mole. And here is what? 17, I guess. 14 plus 3, 17 grams per mole. So which one with the lowest mass? Do you know the lowest number now? So methane will run faster, methane will diffuse faster. Everyone, methane what? Diffuse faster. Methane will diffuse what? Faster. Methane what? Ammonia. Ammonium is NH4. Do you understand? Methane what will diffuse what? Faster. Class, hope it is making sense to us. Alright, hope it is making sense to us. Hope it is making sense to us. Class, hope it is making, it's a cheap one. Hope this question is making sense. It's not hard at all. Just pay attention, man. That's all I need from you. Just pay attention. You are good to go. Alright? So yesterday you have not watched my full lesson, alright, on organic chemistry. 7 hours plus. That lesson we went into another state. I went to another state. Like, it was so crazy. I can't imagine myself doing that. Like, it was so crazy.
Can I do that again? Maybe in another topic? 7 hours? I can't imagine. 7 hours, 35 minutes. It's no joke. I stood here for 7 hours teaching. Ha! It's crazy, like, it's crazy. All right. All right, let us work on more questions. Okay, is that world record? I don't know. Maybe in Nigeria, maybe it's a world record, but maybe like in teaching chemistry, Nigeria I'm specific. Do you understand? I'm telling you about Nigeria. Maybe people abroad, all those are white people, maybe they have done it already. They have not maybe they have done. I've seen 12 hours lecture on your organic, like 12-hour lecture, 12 hours plus, crazy. People have done these things. But in Nigeria, I've not. But in Nigeria, basically, maybe in chemistry in Nigeria, I can say I'm the one who have done the longest class. All right. Somebody said I should not. Somebody said Guinness Book of Record. Somebody said I should not do it again. No, it's like, somebody said she finished the lecture for 4 days. Oh my God, it's crazy. Like that night, I went into Merlin State. You know they call Merlin or Avatar State. It was crazy, but thank God we are done. Right? So, all right, guys. I want to look for more questions. So, relax. Another one. Let's work on another one. This one, let us. No. All right. Let's work on. Now, people have been complaining. Where is this density now? Where's density we're talking about? You will see a question on density now. So cheap. So cheap. Let's work it out together. This one is so cheap. Let us work it out together. Let us work it out together. Oh my God, I'm so excited. Oh Jesus, always say I should make it a day. Let me teach for 1 day. Oh my God. No, I don't think when I browse, I said, okay, let me check what is the maximum time for live stream on YouTube. I think it's 12 hours. The highest you can do on YouTube is 12 hours. I think so currently on the way 2026. Yeah, I think it's 12 hours. The maximum time from what I just technically unlimited, you can stream. Okay. If you want to stream. Oh, look at it. I've seen, look at what YouTube said from what I browsed. They said it's like you can be streaming, you can be streaming. Like you can be streaming for days, months, years, if you have data, everything is light, electricity. But the out of your stream, the one that will be saved is 12 hours. So the maximum time you can actually stream and all the classes will be saved is 12 hours. Who is the oldest subscriber? I say. All right. It's 12 hours, like I've literally said it. Saved replay, maximum 12 hours. Live streaming, no real limit, can run completely. Do you understand? Like you can literally stream for more than Oh, please be clear now. Be clear now. What's wrong with you? The board is not. It's blurry now. I don't know. Maybe I should. All right. It's better now. It's better. So it's 12 hours. That's the one you can actually. So I did 7 hours. that 7 hours plus. So let's work on this one. It says this one's so cheap. It says the densities. Look at it. The densities. Not one of two gases. Of two words, gases. Everyone. Gas X and Y. They gave me 0.5 gram per dm cube, that's the unit for density, and 2.0 gram per watt dm cube, respectively. Do you know what the term respectively means? It simply means that this first value is for the first gas, and this second value is for the second gas. Class now, are you there? Question now says, what is
the rate of diffusion of gas X relative to Y. A 0.1, B 0.5, C 2.0, and D 4.0. Let's work it out together, everybody. It's too cheap. This one is too cheap. Who said back then he usually wears lab coat to stream? Somebody said he knows me. Oh my God. Yeah, back then I used to use the lab coat to teach. When I started YouTube, and when I was in like uni, I used to use lab coat, many things, like it's crazy. Alright, so there are two gases, gas X and what? Gas Y. Are you listening? So what's the density of this gas? Remember, since it was the first gas mentioned, it's going to be one. It's going to be for the first. This second, since it's the second gas mentioned, it's going to be 2, right? So what's the density of this one? It was gas X will be the first density. Hope you are going at 0.5 gram per dm cube. Gram per watt. What about this one? 2.0 gram per watt dm cube, everybody. So what do? Everybody, they said what is the rate of diffusion related of X relative to Y? So basically it's going to relate rate of diffusion and density. So what's the formula again? Rate 1, look, I've not forgotten. Rate 1 divided by everybody. Rate 2 is equal to root of what? Density 2 over root of what, everybody? Density 1. I've worked on this thing before now. So basically, who is 1? Is it not gas X? Have you forgotten? Who is 2? Is it not gas Y? Make mistake now. So basically, we are looking for the rate of this relative to this. We are looking for the rate of gas X relative to gas Y is equal to the root. So what do we do, everybody? I think if I do like this, you will follow me. So basically, it's going to be rate 1, who is X, over what? Rate 2, who is Y. Alright, class, hope you are following me now. Is equal to all root of densities. Density 2. Density 2, everybody. Who is density 2? Who is density 2? Who is density 2? Don't make mistake. 2. Who is like density 2? Is it not 2? Is it not 2 gram per dm cube over density 1? Density 1, who is it now? Who is the first density? 0.5 now, everybody. So what do we do next? We now come down and finish it and say, okay, after they are writing in a rate, the rate 1 of the rate of X over rate what 2 of the gas Y is equal to, then I say, what is the rate of division of X relative to Y? That's X relative to Y, X relative to Y. So divide. You come here and say, look at what I want to do my calculator now. Alright? You come here and say, don't forget square root, oh please, don't forget it. 2, look at what I'm doing now. Root of 2 over root of 2 divided by 0.5. Alright, everybody look at now. Everybody look at the answer. Alright, the rate of gas X relative to Y is 2. Because the density, look at it now, everybody. Are you not seeing what we are doing? The answer is 2. Don't waste time. So the answer will be 2. Yes, the rate of gas X relative to Y is 2. Option C. Class, is it making sense? Let me know in the comment section if this question is making sense to us. Right? Let me know in the comment section if this question is making sense to us. Let me know in the comment section if this question is making sense to us. Is it making sense to us? Let me know in the comment section. Is it making sense to us? Let me know in the comment section. Alright, so I can move further to more practice questions. They're all cheap. Right? They are all cheap. Alright, another one. Alright, good one. So another question, everybody, here is it. So let me go and find another one that we need to learn. There you go. That is twice as fast as well. Everyone, this is cheap one, oh. This one is so cheap. They said a gas X diffuses twice, meaning 2 times. Everybody pay attention. A gas X diffuses 2 times as fast as gas Y under the same condition. Are you there? So then I said if the molecular mass of X, gas X is 28, what is the molecular mass or relative molecular mass of gas Y? Class is so cheap. Option A says 112. Option B says 120. No, all these are gram per mole. All right. Option C says. Everybody pay attention. All right, let's remove it because the option just roll it like that. Option C says 56. Option D says 14. So let's work it out together. Let us work it out together. Look at it, so cheap. So this question is relating these gases and molecular mass. Yes, now. So they said gas X diffuses twice as Y. Everybody pay attention. Gas X, we have to understand how this statement is, or how we're going to put the statement in a mathematical form. Everybody pay attention. Just listen, So we can move forward. Please pay attention, Very cheap one. All right. So basically, when they say a gas diffuses a particular times as another gas, remember I'm going to relate it to rate. All right. Rate 1 over what? Rate 2. Everybody listen. Who has this first rate? Is it not gas X? Yes, as the first gas mentioned. Who has second rate? Gas Y. Diffuses fast. Relax. Now, the next say molecular mass. So that means this particular rate will relate molecular. Yes, it will relate molecular mass. Yes, 2 over what? Molecular mass 1. All these are still the building block. You must for you to understand all this. That is why we started from scratch. Do you understand? So basically, my point here is this: a gas X diffuses twice. So gas X. Look at it now, everybody. Gas X diffuse twice. This gas X twice as gas Y. So the reference point now is 1. Let's say gas Y has a speed of 1. So gas X now diffuses twice of that speed twice. That's how it works. If it's gas X diffuses thrice, it's going to be 3 over 1. That's how it works. And if it was gas Y diffuse, if it was maybe they put the statement that they now say gas Y diffuses twice. Why? If Y is going to be down, it will be 2. Do you understand what I'm saying? So that's how it works. Gas X diffuses twice as Y, it's going to be this thing I just wrote on the board. If it's thrice, 3 over 1. If it's 4 times as Y, 4 over 1. Do you understand? Is equal to now root of, guys, who have the 2? Who has the 2? Who has the 2? Is it not Y? Yes, now. Who has the 1? Is it not X? So basically, we are looking for the they said if the molecular mass of X, see, molecular mass of X is 28. Everybody listen. Molecular mass of X is not 28. 1 is 28 now.
divided by what we are looking for, which is what molecular mass 2, which is for the y. It's not hard. Class, what do we now do next? We basically square both sides of this equation. How do you do it? You square this side. Listen now, you square both sides in the sense that you're going to square up and square down. Yes, you square both sides. There are two things. There's a fraction. You square up and square down. Square it here. So that this square will cancel this square root. Because I use the square both sides to cancel this square root in this side. That's how it works. So what do we do next? What do we do next? I'm picking this. I'm writing it here. That means 2. Okay, now 2 squared is what? 4. All over 1 squared is 1. Is equal to, I've removed square, so molecular mass 2, which is for gas y, over 28. So how do I get the molecular mass of gas y? Molecular mass of gas 2, which is y, everybody, will now be equal to 4 times what? 28. And 4 times 28 will now be what, everybody, in the comment section. Class. Hope this is making sense. 4 times 28, that's what? 1, 2. Alright, this is molecular mass of gas. What? Y. Answer A. Class, is not hard. It's not hard. This is not hard. Is it making sense to us? Is it making sense to us? Let me know in the comment section if what I just said is making sense to us. Alright, I'm going to take it again so that it will be clear. Alright, I'm going to take it again so that this thing will be clear. Don't worry. I'm going to take it again so that it will be clear. Eh? It's not hard. It's not hard at all. So cheap. I know the problem is what happened here, all right? It's not hard at all. All right, I'm going to take it again. Okay, look how it works. Better still. Let me take it again, everybody. Let me take it again. Everybody, it was like this. Leave this last part. Leave it. Let's come back here. I said square both sides of the equation, Abi. After you've been able to get here, it's not hard to get here now. That is why don't rush you. Don't rush you. You should always know that the one they call first is your 1. The one they call next is your 2. Do it like that. So here you see this like that so that it will be clear. So here now, after doing this, we are looking for here. How do we get here? You basically need to eliminate this. So you square both sides. So the best way to square both sides is doing like this. You square both sides. Square both sides of the equation. Do you understand what I'm saying? Square both sides first. Do you get what I'm saying? So this guy will square. When this square will cancel this square root, and this one now 2 squared is 4. Are you there? Also, are you aware that when there is a way you have to, like you have a square root, you have a power for a fraction, it will affect the square, the numerator, it will affect the numerator and the denominator. Are you aware about that? Then we can now arrive here. Class, is it clear? So it will be like automatically 2 squared, that is 4. And 1 squared. Class, is it clear? Class, every other part, is it clear? I'm just making sure that it's clear. 1 squared is still 1. Alright? 2 squared. This square will still affect this one. 1 squared. That's why it's what? 4 over 1. 2 squared is 4. Class, is it clear to everyone? Let me know if it's clear to everyone. Let me know in the comment section. Alright? Let me know in the comment section if it's clear. Let me know in the comment section if it's clear. Alright, good one. Good one. Good one, so we can move further. Alright, so we can move further. Good. Alright. All right. Okay. All right. I'm coming. Let us move further. Alright, I'm coming. Alright, let me take you one more time. I'm going to take it here again. Everybody listen. So what will happen is, you know, in mathematics, I'm not going to say it now. Let's say you have a over B. This is a law in indices. And all result of n for this, and the power is n. The power here is 2. Do you understand what I'm saying? So what we have, we have a n over 1 and b raised of n. Do you understand what we have here? So yeah, automatically is going to be what now? 2 raised of 2 over what now? 1 raised of what? 2 is equal to that what now? Molecular mass what? 2 for y divided by what? 28. So automatically number 4 over what? 1 is equal to molecular mass 2y. Hope you understand what I'm saying about 28. So then molecular mass 2 y will now be equal to what? 4 times 28, and that is what now? 112. Class, is it understood? Right? Is it understood? Class, is it understood? Class, is it understood? All right, good one. You know, this one, you know, what we just said now is a law, is a power of a quotient law. Power of a quotient law. This is a mathematics indices. All right. All right, so that is for that. We've done a lot. Like a lot. All right. Let me go and find more questions. Everybody. I'm coming, guys. Class, I'm coming so we can move further. No sign of weakness. Yeah, no sign of weakness. You don't have to be weak. Alright, I'm trying to find more questions pertaining to this area so we can trash it together. Everyone. Where are you now? Where are you? Grahams, where are you? Mr. Grahams, where are you? I want to look for another question. All right. Coming, guys. Trying to look for more questions. Thank you so much. Thank you so much, people. So let us move further. I'm coming in. I'm coming. There's one question I just saw here, the jump pass question. Let us work it out together, guys. All right. I think before I solve that question, let me tell you something again. Let me wipe the board and say something. I want to wipe the board. I want you guys to take note of this statement. Everybody, please, this statement is very important. Everybody, I repeat, this statement is very important. He said, a gas X diffused twice as gas Y. Gas X diffused twice as gas Y. You know, when we got here, we got the equation, the expression to be okay. We are aware that, okay, everybody. So it's not about rate, right? So rate 1, who has rate 1? Is it not X? Over what? Rate what? Listen, rate 2, is it not Y? Relax. Relax. So I think we solved it. There's a question we solved. I want to bring something out first. There's another question I want to bring out, but before I bring that question, I have to tell you guys this thing. Before I want everything to just be clear. I mean, where are you? I saw that question just now. Now, where are you again? Okay, gas X. Now, wait. I have to look for that question so that I can. Everything will just be clear. Okay, I think I've seen it. Okay, let me write it on the board. This is what I have here. So, gas X diffused twice. So, the way gas X diffused, so relating this, is it not gas X diffused twice as gas? So, the gas that they did not mention anything, its reference point will be 1. The baseline will be 1 for that gas Y. Class, are you there? Listen to this thing I just said. It will help you. Gas X diffused twice as gas Y. Are you not seeing what I'm saying? Gas X, which is what? They told me it's twice of Y, so it's going to be 2 of Y. The gas that they don't mention anything for will be always 1. Class, are you there? Class, are you there? Class, are you there? Please. I know I said this so because I want to bring a question that I don't want anybody to be confused at all. Simple. Alright? So can I have the board? Always remember gas X, this one that's why so twice 2 over 1. Everybody, this is another question under Graham's law of diffusion. This is another question under Graham's law of diffusion. This is another question under Graham's law of diffusion. Alright, this is another question under Graham's law of diffusion. Everyone pay attention. Everyone pay attention right now. So it says, the question says, hydrogen, you are seeing now. Hydrogen gas diffuse through a porous plug. Is a statement given to us. Option A has said at the same rate as oxygen gas. I don't know if hydrogen gas will diffuse. We move at same rate as oxygen. I don't know. Let me write out the options first. Option B, at a slower rate than oxygen gas. I don't know. Let us write out the option first. Option C says twice. Listen, as fast as oxygen what? Gas. Option D that says 4 times as fast as oxygen gas. Everyone, 4 times as fast as oxygen gas. Everybody pay attention. Don't rush. Take your time, please. Don't rush. I know I'm saying this. Don't rush. I know I'm saying this. All right? Everybody listen. So let us talk together. it logically, looking at the molecular, now hydrogen is not H2, solve the mass of the molecular mass quickly. It's not 1 times 2, it's going to 2 gram per mole, 2 gram per mole, class, are you there? What about oxygen gas? The reference point in this question is not oxygen gas, which is O2, and oxygen is 16 times 2 now, 32 gram per mole. Class, hope you are aware about all this, hope you are not fast. So, looking at the way their masses are, this one has smaller mass, which is 2 gram per mole. So, if you want to run race, hydrogen will run faster than oxygen. So, will they move at the same rate? Option A is rubbish. Option A is not correct. They cannot move at the same rate. They cannot diffuse at the same rate because this guy mass is not the same as the other guy mass. That's molecular mass, I mean. Do you understand? At a slower, no, now, how will you move at a slower rate? They cannot move at a slower rate now because hydrogen cannot move at a slower rate than oxygen now. Because hydrogen will move at a faster rate. If faster rate was it, it can be correct. Because are you there? If faster rate was there, listen, oh, they now gave us option C as D as a mathematical stuff. They said hydrogen will move twice as fast as oxygen. Option D says 4 times as fast as oxygen. Let's solve it together. Everybody watch. Remember, we're going to use rate and its molecular mass relationship. There's no density here. So rate 1, everybody who has rate 1 is in oxygen gas. Sorry. Who has rate 1 is in hydrogen gas. I don't get the first gas mentioned now over what rate 2. Rate 2 has it. Who has rate 2? Is in oxygen gas is equal to relative molecular MM2. Who has it now? Oxygen gas over MM1. Who has that one now? Hydrogen gas. Everybody, let's work it out together. Simple question. People will be failing questions. We don't fake questions here. So rate 1 hydrogen gas over rate 2 oxygen gas. Listen, what is the molecular mass of oxygen gas? 32. So root of 32 gram per mole. Well, the molecular mass of hydrogen gas is not to. Everybody, let's evaluate this part of this fraction. Yes, now don't do that here. Alright, let's evaluate it. Alright, let's evaluate it. 32 quickly. Divided by 2. Alright, divided by 2. Divided by 2. That is 4. Add 4. Add 4. Look at me. Look at it. Add 4. Add 4. Add 4. Add 4. You know see 4. You know see 4. Root of 32 over 2. Add 4. Alright, so automatically the rate of diffusion of hydrogen gas as compared to the rate of diffusion of oxygen gas is 4. Alright, literally it's 4/1 actually. You know, see they don't mention because we are looking for the rate of hydrogen to oxygen. So hydrogen will diffuse 4 times as fast as oxygen gas. Class, are you there? 4 times as fast as oxygen gas. Class, is it making sense? Hydrogen will diffuse 4 times, not 2 times. 4 times as what oxygen gas. Are you getting the point? So that's how it works. 4 times as fast as oxygen gas. 4 times as fast as oxygen gas. Alright? Class, is it making sense? Class, is it making sense? Let me know in the comments. Class, is it making sense? Let me know in the comment section. You know, when they get a value for relative rate of this to the other, alright, most times it's for the one. The first one they're talking about, alright, the hydrogen gas relative to the other one. The first gas has relative to the other. So what you're going to get is this the relative rate of this to that. So this one will diffuse 4 times as this than the other one. So that means, alright, that means this one will run 4 times faster than what oxygen gas. Class, is it making sense? Class, is it making sense? Let me know in the comments. Alright? You have to square, please. You have to square, please. You have to square, please. Alright? So that is for that. Alright, that is for that. All the questions here, I've trashed them. I've trashed them. I saw another one here. So cheap. All of them are so cheap. You can literally solve all the remaining questions here. I've done all the works. I've done all the work, actually. I've done all the work. Alright, guys. Alright, guys. Alright, guys. With all this said, we are done with this aspect of chemistry called the Graham's law of diffusion. Alright, you can see we've been able to deal with so many aspects in chemistry, and we are done for now. God bless you all. I wish you guys good luck in your exams, and God bless everybody. See you guys when I see you guys, and God bless everybody.